Welcome to the DIY Honda Garage channel. DTC P0111 indicates an issue with the intake air temperature, IAT, sensor's circuit range or performance in the Honda Accord models from 2008 to 2012. The IAT sensor is crucial for determining the temperature of the air entering the engine, which is essential for calculating the correct fuel-to-air mixture. This ensures optimal engine performance, fuel efficiency, and emissions control. This diagnostic trouble code, DTC, may signal a malfunction in the IAT sensor itself, the engine coolant temperature ECT sensors, or wiring connections. A limited range or performance problem can result from faulty sensors, poor electrical connections, or internal ECM, engine control module issues. A thorough diagnostic approach is necessary to identify the root cause accurately. The intake air temperature IAT sensor measures the temperature of the air entering the engine and provides this data to the engine control module, ECM. This information is vital for calculating fuel delivery and ignition timing. In the Honda Accord, the IAT sensor is typically located near the mass airflow MAF sensor, often integrated within the same housing. It plays a crucial role in ensuring that the engine runs smoothly and efficiently. If the IAT sensor malfunctions, it can lead to a range of performance issues, including poor fuel economy and increased emissions. Additionally, the sensor itself is connected to the ECM, which interprets the signals received and makes necessary adjustments to the engine operations. Several factors can trigger DTC P0111, and it's essential to assess them systematically. The most common cause is poor electrical connections, which can interfere with the signal between the IAT sensor and the ECM. Loose terminals can lead to intermittent signals that the ECM misinterprets, causing performance issues. A faulty IAT sensor itself may also be the culprit. It could be providing inaccurate temperature readings or failing altogether. Additionally, wiring issues such as frayed or damaged insulation can create similar problems. Each of these possibilities must be thoroughly checked to ensure an accurate diagnosis and effective repair. When DTC P0111 is present, several symptoms may become evident during the vehicle's operation. Drivers may notice a decline in engine performance, characterized by sluggish acceleration or unresponsiveness. Fuel efficiency may also take a hit, resulting in more frequent trips to the fuel station. Furthermore, a malfunctioning IAT sensor can lead to increased emissions due to improper fuel-air mixture adjustments. Onboard diagnostics may reveal other related trouble codes, complicating the symptoms. It's crucial to address these issues promptly to maintain vehicle efficiency and compliance with emission standards. The first step in troubleshooting DTC P0111 requires checking for poor connections or loose terminals at the engine coolant temperature ECT sensors 1 and 2, as well as at the MAF IAT sensor. Poorly connected or corroded terminals can lead to inaccurate readings from the IAT sensor. It's vital to inspect these connections thoroughly to identify any signs of wear, corrosion, or damage. If any issues are found, repairing them may resolve the DTC P0111 without further action. If the connections are intact and secure, move on to the next troubleshooting step to further diagnose the issue. This systematic approach is essential for accurately identifying the root cause of the problem. After ensuring that the connections are secure, the next step involves removing the MAF sensor/IAT sensor from its housing. This step is essential as it allows for further testing of the sensor itself in a controlled environment. It's important to handle the sensor carefully to avoid any damage to its components. Once removed, allow the sensor to cool to ambient temperature. This ensures that the readings obtained in later steps reflect accurate environmental conditions. Always prioritize safety during this process, making sure to adhere to the manufacturer's guidelines for sensor removal and handling. In this step, it's crucial to allow the MAF IAT sensor to return to ambient temperature before conducting any further tests. The sensor must be at the same temperature as the surrounding environment to ensure accurate readings during the next step. Use a reliable thermometer to verify the ambient temperature precisely. Documenting this reading is essential for comparison with future data, particularly the temperature readings obtained from the sensor later in the diagnostics. Accurate ambient temperature is vital for diagnosing potential issues related to DTC P0111, ensuring that observed sensor values reflect true performance. After allowing the sensor to cool to ambient temperature, the next step involves reconnecting the MAF sensor/IAT sensor to its 5P connector. It is critical to ensure that the connection is firm and secure. Yet, the sensor should not be installed in its housing during this test. Next, turn the ignition switch to the on position. 2. To power the vehicle's electronic systems while avoiding engine start. This enables the diagnostic test tool, HDS, to access real-time data. At this point, you'll need to quickly take note of the IAT sensor value in the data list. This reading is essential for comparison with the documented ambient temperature, illuminating any potential faults. This step requires careful analysis of the IAT sensor value obtained from the HDS. Specifically, you need to compare this value to the recorded ambient temperature from earlier. If the IAT sensor reading differs from the ambient temperature by 5.4 degrees Fahrenheit or Celsius and more, it suggests an issue with the sensor or its circuit. If this is the case, you should proceed to step 13, where you may need to replace the sensor. Conversely, if the reading is within acceptable limits, continue to step 9, where further diagnostics can help identify more subtle issues affecting the IAT sensor's performance. If the IAT sensor reading was within acceptable parameters, the next step requires disconnecting the MAF sensor/IAT sensor from its 5P connector. In this step, you will use a heat gun to blow hot air on the MAF sensor/IAT sensor for a few seconds. It is essential to avoid applying heat for too long, as doing so could damage the sensor itself. This brief exposure to heat mimics a change in the intake air temperature, which should prompt a corresponding response from the sensor. The goal is to check whether the IAT sensor reacts adequately by indicating a change in temperature corresponding to the applied heat. This test can be critical in determining whether the issue is intermittent. After applying hot air to the sensor, you'll reconnect the MAF IAT sensor to its 5P connector, again ensuring that it is not installed in its housing. This step is crucial for checking how the sensor responds to rapid temperature changes. Using the HDS, monitor the IAT sensor value once more. In this step, you're looking for a significant change of 63 degrees Fahrenheit, 35 degrees Celsius or more. A response of this magnitude indicates that the sensor is functioning well at this moment, suggesting an intermittent failure. If the sensor does not respond appropriately, it is likely malfunctioning, and further investigation or replacement would be warranted. If the IAT sensor failed to show an adequate response in the previous step, the next course of action is to turn the ignition switch to lock 0 to ensure all systems are off while you work. At this stage, replacing the MAF sensor/IAT sensor becomes necessary as it appears to be faulty. The replacement should be performed carefully, following the manufacturer guidelines to avoid any mishaps. and accurate installation will help prevent further issues down the road. It is essential to ensure that all connections are secure and the sensor is properly configured before proceeding to test the system again, ensuring it's operating as intended. Following the replacement of the sensor, the next step is to turn the ignition switch back to the on position. In 2, this action will power the vehicle's electronics, making it possible to communicate with the Engine Control Module, ECM. It's crucial to reset the ECM-PCM using the HDS tool. This reset clears historical error codes, including DTC P0111, from the system and allows the ECM to recalibrate and adapt to the new sensor input. Following this, an idle learn procedure should be triggered. This procedure will help the engine management system tune the engine idle based on the new sensor's parameters and ensure the vehicle runs smoothly after repairs. Once you've reset the ECM-PCM and performed the idle learning procedure, it's crucial to check for any pending or confirmed DTCs using the HDS. Is DTC P0111 still indicated? If it appears again, it suggests that further inspection is needed, particularly focusing on poor connections or loose terminals at the MAF IAT sensor and the ECM. This might indicate persistent wiring issues or sensor malfunction despite replacement. However, if DTC P0111 does not show up again, it signals that the troubleshooting process is complete. Be sure to verify that no other pending or confirmed DTCs are present, addressing any additional issues accordingly. After completing all the troubleshooting steps and replacing any faulty components, it's essential to verify the repair's success. Start by clearing all diagnostic trouble codes, DTCs, from the ECM using the HDS. Following this, a thorough road test should be conducted to ensure the vehicle operates as expected. During the road test, closely monitor the intake air temperature IAT readings to confirm they fall within acceptable ranges, ensuring proper operation of the new sensor. This verification is critical to ensure that the completed repair has resolved all issues and that the vehicle can perform optimally. If any issues persist, a re-evaluation of previous steps may be necessary. To prevent future occurrences of DTC P0111, regular maintenance checks should be a part of your vehicle care routine. Periodic inspections of electrical connections, particularly at the MAF IAT sensors, can help identify potential problems before they escalate. Keeping connections clean and free from corrosion or wear is vital for ensuring the proper function of the sensor and the vehicle's performance. Additionally, proactively replacing sensors based on manufacturer recommendations or observed performance can prevent unexpected breakdowns. A well-documented preventive maintenance schedule can aid tremendously in prolonging the life of your vehicle and its components, ensuring they operate smoothly over time. Diagnosing DTC P0111 requires a meticulous approach to uncovering the underlying issues affecting the intake air temperature sensor's performance. By closely following the outlined troubleshooting steps, technicians can systematically identify and rectify problems, ensuring optimal vehicle performance. It's essential to verify all repairs through comprehensive testing following replacement to guarantee resolution of the issue. Regular maintenance and inspections can further help prevent the reoccurrence of DTC P0111. Understanding the role of each component and adhering to systematic troubleshooting protocols greatly enhances diagnostic accuracy and repair efficiency. Please like and subscribe to the channel. See you next time.